Let's take a look at the process of finding the inverse of an exponential function. Before we dive into the algebra, let me just mention exponential functions are one-to-one functions. They're always increasing or always decreasing. And so each y value is only reached by a single x value. And so that's what we mean by one-to-one. And this is important because it means that the inverse will be a function. Now, we're going to use our four-step process. The first thing I want to do is simply replace the f of x symbol with y. And then in our second step, the key step for finding the inverse, I want to switch the x and the y. Because that's what an inverse does. It switches the x and the y values. And now we can solve for y. And so our first step is just a regular sort of arithmetic thing. I can subtract 2 from both sides. I get x minus 2 equals 3 to the y minus 1. But now y minus 1 is up in this exponent. And so to get to that, I need a logarithm. And so this next step is going to be a logarithm step. I'm going to rewrite this exponential equation as a logarithmic equation. And so to do that, the exponent comes down. I get y minus 1. The base stays the same. It's still going to be base 3, but this time it's going to be log base 3. And then the x minus 2, the thing that was outside all by itself, is going to go inside what's called the argument of the logarithm. So x minus 2 goes inside the logarithm. Y minus 1 goes outside by itself. The exponent comes to the front by itself. And of course, base 3 is still the base of the logarithm. So we've converted from an exponential expression to a logarithmic expression. And the rest of my problem is pretty simple. I just need to add 1 to get y by itself. So that 1 is going to be on the outside of the logarithm. We end up with y equals log base 3. X minus 2 is inside. That's what the logarithm is being applied to. Plus 1 is on the outside. And to finish the problem, we started with f of x. So let me write my final answer as f inverse. F inverse of x is log base 3 of x minus 2 minus 1. So in a similar way, we could write the inverse, the inverse of a logarithmic function. We're just going to basically do what we just did, but in reverse. Logarithmic functions are also one-to-one, right? They tend to always be increasing functions, or they can sometimes be decreasing. But each y value occurs at only one x location. So there's only one x that's going to lead to any particular y value. So again, it's one-to-one, which means that the inverse is going to be a function. Our process will be similar. I want to start by replacing g of x with y. And what comes next is I want to do the all-important step of switching x and y, because that's essentially gives us the expression for the inverse, because the inverse reverses those roles of x and y, inputs and outputs. And now I need to solve. And so this time I'm going to start by multiplying by 5 to get rid of that 1/5. So if I multiply by 5 on both sides, I end up with 5x equals log base 2 of y minus 3. And now I have a logarithm all by itself over here. So to undo that, I want to do the logarithmic step, but in reverse. I'm going to create an exponential expression where 2 is going to be the base. So the base stays the same. We're going to have base 2. The exponent is going to be this thing that was outside. So the exponent is going to be 5x. And then the this part, y minus 3, is going to be outside by itself. The argument of the logarithm, the thing that was inside the logarithm, is going to be out by itself. And so to finish solving my equation, I now just I want to solve for y, and so I just have the simple step of adding 3 to both sides. So I end up with y equals 2 to the 5x plus 3. Or written as our final answer, step 4, I want to put it back into function notation. This is g inverse of x equals 2 to the 5x plus 3. I hope you enjoyed the video. Thanks for watching.